In Chapter 8, Part 6, we are going to look at simplifying rational expressions. Prior to doing that, we're going to take a look at number 69, which says to factor x squared minus 3x minus 18. So we are going to set up the diamond and the rectangle, and we need two numbers that multiply to give us negative 18x squared, but add to give us negative 3x. So this is going to be negative 6x and 3x. We're going to plug them back into the rectangle, and then we are going to find what's going to be our greatest common factor, or the dimensions of our rectangle. So x squared minus 3x minus 18 is x minus 6 times x plus 3. So that would be the factored form. So in example 1, we are going to simplify this rational expression, and we're going to look at it at two parts. So we have the numerator and we have the denominator. So focusing on the numerator, x minus 4 is already factored out. We can't do anything else with that. The greatest common factor is only 1, so it's going to stay x minus 4. Moving on to the denominator, we have 3x squared minus 12x. Since we are missing that constant term, we are not going to do a generic rectangle and a diamond. Instead, I'm going to factor out and look to see what is my GCF. Looking at my factors, they have a 3 in common, and they also have an x in common. So my GCF for my denominator is going to be a 3x. So that means if I take my 3x squared minus 12x and I factor out a 3x, I can see what I'm going to multiply by 3x to get my 3x squared. So that will be an x, and this is going to be a minus 4. So in my denominator, if I factor out 3x, I have x minus 4 left over. Now what happens is, once we factor out the numerator and denominator, and because we are multiplying the 3x and the x minus 4 in the denominator, we are looking to see, can we form that giant 1? So if you recall from last year, or even when we worked with our exponents, making that giant 1, the x minus 4, since it's in the numerator and denominator, is going to simplify to 1. So left over, we're going to have a 1 in the numerator and a 3x in the denominator. So x minus 4 over 3x squared minus 12x simplifies to 1 over 3x. Taking a look at example 2, again we're going to focus on the numerator first, v minus 5, which is already factored out. We can't do anything else with that, so it's going to stay the same. But the denominator is a quadratic expression, and there is no GCF besides a 1, so we're going to start with our rectangle and our diamond. So we've had a lot of practice working with these. So we need two numbers that multiply to give us 25v squared, but add to give us negative v. So that's going to be a negative 5v and a negative 5v. And then we can find our dimensions of our rectangle. So that's going to be v minus 5 times itself. So v minus 5 times v minus 5. So we're looking to find that giant 1. So we have a v minus 5 in the numerator and denominator. That's going to simplify to 1. So left over in the numerator is just going to be a 1 over v minus 5. In example 3, this is a little more intense than the two previous examples. So again, we're going to focus on the numerator first, and we do not have a GCF other than 1, but we can break this down and do a diamond and a rectangle. So we need two numbers that multiply to give us 12x squared, but add to give us 8x, and that's going to be 6x and 2x. And then we can find our dimensions of our rectangle. So our numerator is now x plus 2 times x plus 6. The denominator Same deal, we have a GCF of 1, which is not going to really do anything. So we are going to set up our rectangle and our diamond. So we need two numbers that multiply to give us negative 18x squared, but add to give us 3x. So it's going to be a 6x and a negative 3x. Again, it doesn't matter where you put them in the rectangle, and then you're going to find the dimensions. So we'll have x plus 6 times x minus 3. So we are looking to find that giant 1, and if you notice, we have an x plus 6 in the numerator here, and we have an x plus 6 in the denominator. And even though they're not right on top of each other, we can still simplify them to 1. So our simplified rational expression is going to be x plus 2 over x minus 3. And be careful, you can't cross out these x's here. Right here, you can't cross them out because you're adding 2 and subtracting 3. So it is just going to stay x plus 2, so think of them together, you can't break them apart, over x minus 3. The last example, 4, that we're going to look at today is b squared plus 3b minus 28 over b squared minus 49. So again, same setup. I'm looking at my numerator, looking for a GCF. We don't have one other than 1, so I'm going to set up my generic rectangle. So we need two numbers that multiply to give us negative 28b squared, but add to give us 3b. So that's 7b and negative 4b. And then we are going to find the dimensions of our rectangle. So we have b plus 7 and b minus 4 in the numerator. In the denominator, b squared minus 49, we do not have a GCF other than 1, so we can set up the rectangle and the diamond. So we need two numbers that multiply to give us negative 49b squared, but add to give us 0b. So this is going to be negative 7b and 7b. And this is one of the special factoring patterns, if you remember from a previous screencast. And if you don't, that's okay. You can still work it out like this. So we're going to have b minus 7 and b plus 7. So we're looking to see what we can eliminate, what can simplify to 1. So the b plus 7s can be reduced. So we are left with b minus 4 divided by b minus 7. So that would be our simplified rational expression.